My name is Mohammed. So in this video, we'll be telling you about our project for this course. So in our brainstorming session, we came across the problem that deaf people cannot always communicate with other people due to the fact that not everyone knows sign language. So for our objective, we decided to design a measurement system that can read sign language. How this is going to be done is by the position of the fingers. This will translate it into electrical signals, and this will allow deaf people and other people to communicate.
So the way this is going to work is we have a glove. And on the back of this glove, there are going to be 5 strain gauges, one for each finger. All right, now each strain gauge is connected to an elastic band through which we're going to be measuring the strain. And depending on the strain in each elastic band, the strain gauge is going to output a signal. And then using the DAC, we can compile all of these signals into a long string that can then be translated into various things. For example, letters, which is our primary sort of objective.
Components. So basically, this is a list of components that we compiled for this project. So one of the components is the elastic band, which is a medium that we're going to be measuring. The elastic band is going to stretch, it's going to strain. We're going to be measuring that through our strain gauge. We're going to need 5 of those sensors because there's 5 fingers in the sensors. We're also going to need the DAQ. That's going to be the input of how we're going to measure the things. Wires, because wires and soldering, we're going to connect those together, and that's how we're going to transport the signals into the DAQ and into the computer. And the glove, which is like the motherboard, the foundation of our thing.
There's a lot of applications for this kind of system. And while we're talking about communication with the deaf, there's a couple of things that come to mind. For example, home translation sound systems that can be used for deaf people to communicate with people inside their home. Another one is a carry-along device that a deaf person can take with them. They can just use their hand and the system can translate that into sounds. And this can also be used in public places like hospitals or supermarkets or those kind of things. And another application is virtual reality or augmented reality or even Xbox Connect type of games. A sort of fun use of this technology instead of a sort of serious communication type thing. Another application could be to control robots or exoskeletons like in Halo or in Pacific Rim.
In short, we're going to be making a sign language translator, and we're going to be doing this using a strain gauge that will measure finger position and will translate into electrical signals. And this can be used in daily life of deaf people and mute people. And this, based on these principles, several applications can be formulated.